Good morning, students. We are going to discuss some of the main points of section 1.1 and 1.2. 1.1 and 1.2 deal with patterns and problem solving. I do expect you to read the two sections, but I'm going to highlight a few things that are important. Mostly the chapter 1, the first chapter of the book, containing two sections, deals with patterns. And we are going to identify two or three types of patterns, but among those two or three types of patterns, two of the most important patterns are arithmetic sequence and geometric sequence. So let's go ahead and talk a little bit about the arithmetic sequence, okay? All right, guys. In an arithmetic sequence, and I know some of you have seen it before, okay? Um, we have something that looks like this. I'm going to give you an example. 2, 5, 8. Let's put another term, 11, so on. Now, what's going on? Well, it seems like each term is 3 plus the previous term. The next term goes up by a fixed number, and that fixed number is called the common difference. Okay? That fixed number is called the common difference. The common difference for this arithmetic sequence is 5 minus 2, which is 3, 8 minus 5, which is also 3, 11 minus 8 is also 3. So the next term, which is not listed here, will be 11 plus 3 or 14. So that's the basic definition of arithmetic sequence. Of course, the common difference could be -2, but we're not going to get into it and it won't hurt anything. We can just deal with it when we encounter it. Don't worry about it. So this is called an arithmetic sequence. Now, the good news is we will do actually two things, only two things with arithmetic sequences. So we are going to find the 10th term or 12th term. Now, you might say you can find the 12th term by finding all the terms in between. Well, that's going to be very tedious if I ask you to find the 100th term. So how do you find the 100th term of an arithmetic sequence? So let's look at this pattern first. Okay, let's look at this pattern first. By the way, A subscript 1 is called the first term. Okay. A little technological difficulty, but don't worry, we'll resolve it. Right here. All right. A subscript 1 is the first term, okay, which happens to be 2. Okay. A subscript 2 is the second term. I'm just listing, which happens to be 5. And A subscript 3, the third term, in this example happens to be 8. And that's good enough for us. Now take a look at what's going on. Okay. To get to 5, which is our second term, we take the first term. We take our first term and add common difference, which is 3. I'm just going to write D here. Okay, common difference, D. Let's fix that. It's not fixing really, but we're going to use D to represent common difference. And D is 3 here. Now, to get to the third term, I can add the common difference to A2, or I can add to the first term the common difference twice. Now, this pattern is extremely important. Take a look. And let's do one more. Let's do one more. The next term, which was A4, which is 11, and that's going to be the common difference plus 3 times D. And you really want to understand it, and we're going to generalize it. We're going to say the nth term of an arithmetic sequence, and we're going to write it like this, A subscript n, and I don't know what it is, so I don't need to put 11 here, is going to be the first term plus n minus 1 times d. So this formula right here, let me see if I can highlight it nicely. This formula right here is very, very important. Okay, this formula allows you to find the nth term of any given arithmetic sequence. For instance, if I ask you to find the 50th term, and you don't want to find all the terms in between, right? You don't want to, because it's going to be a waste of your time. The 50th term. Well, according to this formula and according to our argument, the 50th term will be the first term plus not 50, but 49 times d. And d turns out to be 3, and which is, I'm going to use my calculator if you don't mind. 49 times 3. 49 times 3 plus 2 turns out to be 149. That sounds about right. 149. So what did we learn, guys? We learned what an arithmetic sequence is, and we encountered a new word, common difference. And we also learned how to find the nth term of an arithmetic sequence. And we now know a formula for finding the nth term of any given arithmetic sequence. All right. Now, we're going to talk about geometric sequence. All right. What are geometric sequences? So let's see if you can see what's going on. What am I doing? What's going on here? What kind of pattern do you observe? Well, it seems like I'm multiplying each number by 3 to get the next number. So 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54. And I know, I'm pretty sure it is, but I'm going to check it. 18 times 3 is 54, so we are fine. I do like to check my math in class when we teach. Our students catch us when we make a mistake on when we're recording something online. That's not happening, so it's a little hard. So anyway, so in a geometric sequence, we have something called common ratio. In this case, the common ratio is 3. Now, to find the common ratio, once you establish that a sequence or a pattern is geometric, you you find the common ratio by dividing a term by the previous term. 6 divided by 2 is 3. 18 divided by 6 is 3. 54 divided by 18 is 3. That's how you find the common ratio. So just like before, guys, how do we find the nth term of a geometric sequence, like the 50th term, the 60th term? Now, so A subscript 1 is 2. A subscript 2 is, I'm just going to write 6 for now. I'm going to break it down in a second, and then you'll be able to see the pattern. A subscript 3 is 18. All right, that's good enough. The first term is the first term, just like arithmetic sequence, A1 is the first term, A2 is the second term, A3 is the third term, so on and so forth. Now, to common ratio, we generally use the letter R to represent common ratio. Okay, so to find A2, what did I really do? I took my A1, the first term, and multiplied it by the common ratio once. Okay, now to find the third term, I could have taken the second term multiplied by the common ratio R, but my second term is really A1 R, and if I multiply it by R again, it'll be R squared. Okay, the third term, fourth term, arguing exactly the same way, is really the third term times R, and that's going to make the third term times R, or however you want to say it, the first term times R to the power 3. Your choice. Now, what pattern do you see? Do you see when this subscript is 2, this power is 1? There's no power, so that's 1. The subscript is 3, so the power is 2. If the subscript is 4, the power is 3. This pattern continues, and the general nth term for an arithmetic sequence can be determined with the help of this formula using the argument that we have provided so far. Now, don't forget the -1. Okay, this is also a very important formula. And you want to keep it straight. You want to make sure you understand it, all those things. All right. Okay. Now we're going to talk about something that's related to arithmetic sequence. Let me use a new slide. Okay. We will find, again, we are now finding the sum of an arithmetic sequence, any arithmetic sequence, sum of an arithmetic sequence. Why do we need capitalization here? How do we do that? And what does that even mean? Okay. Well, let's start with a very simple example. All right, guys? Very simple example. Let's say 1 plus 2 plus 3 plus 4 plus ... plus 100. This is an arithmetic sequence, and I'm taking the first 100 terms, the first, the second, the third, 1, 2, 3, 4, all the way up to 100. This arithmetic sequence has a common difference of 1. 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1. You get the point. I want you to find the sum of this expression. What is the answer if you add 1 to 2 to then the sum to 3 and then the sum to 4, so on and all, add all the way up to 100? Well, it's, of course, you can use your calculator and sit there forever. I don't think that's the goal. We're going to use a technique called Gauss's method. Gauss was a well-known mathematician, and we are told that when he was very young in grade 5 or grade 6, he invented this method, and we still use this method. Okay? Now, Gauss's method does this. Okay? We write the sequence in opposite order. All right. And we observe that if we add each pair, vertically, 100 plus 1, 99 plus 2, and 98 plus 3, 100 plus 1, we're going to get a string of 101. Straighten it out, okay? Better. And you really want to see it. So if I add each pair, 100 plus 101, 99 plus 2 is 101. I would have had 98. 98 plus 3 is also going to be 101. And 100 plus 101, 100 plus 1 is obviously 101. Kind of intuitively, it makes sense because in the top sequence, it's going up by 1. In the bottom one, it's going down by 1. So if you go up by 1 and then you go down by 1, your sum will not change. But how many times 101 appears here? Well, that's not that difficult. The first line has 100 terms. The second line has 100 terms. We paired them up. The answer should be 100. So this is equal to 101 times 100. Right? Now, I am interested in this sum. I am interested in this sum and this sum alone. But I added this sum twice. So I take this and divide it by 2. And whatever that turns out to be, I'm going to use my calculator just to be on the safe side. I'm getting 5,050. So once again, you want to follow the argument. And this is the basic Gauss's method. Now, the catch is, there is a catch. I found the sum of this very nice and clean arithmetic sequences. Now, I'm going to give you an example where it's going to be a little more complicated. Okay? And let's do that. You can use the same technique or a very similar technique. Let's make the sequence a little more challenging. What's that supposed to mean? Well, let's do something like this. Let's start with 6 plus. It's an arithmetic sequence. We're finding the sum of this very arithmetic sequence. Let's say it's 13. Let's say this is 20. And if this is an arithmetic sequence, you can already see that the common difference is 7, right? Okay. So this is an arithmetic sequence, and the common difference is 7. Let's write it down. I'm just going to write D. Let's make sure we get that. It's an arithmetic sequence. Okay, that has to be established because we're finding the sum of arithmetic sequences only. And here, the common difference, I'm just going to write D. D is given 7. I can see it. Now, you might wonder, how do you know 706 is there? Well, let me tell you, it is. Okay? You can find it, and we're going to work with that a little bit. Now, everything looks fine. Everything is clean. But there is one little catch that I don't know what number this what is the position of this term? Is this the 700th term? Is this the 10th term? I don't have the time to find all the terms in between. That's going to be a waste of my time. But remember, we learned a formula that allows us to find the position of the term from one of our previous slides. So let's bring that guy here. Okay, I'm going to say, suppose this is the nth term. I'm just going to just say it. I don't know what n is, but I'm going to try to find it. That's my goal. Okay, I need to know the value of n. Okay, but I do know one thing. I do know one thing for sure. A subscript n is the first term plus n minus 1 times d. That's the formula we had. That's the formula we use to find the position of the nth term or the value of the nth term. Now here, if you pay attention, we know everything. We know everything. A subscript n turns out to be 706 given. A1 turns out to be 6. D, common difference turns out to be 7. N minus 1, I don't know. I'm trying to determine the value of n. Now I'm going to do a little bit of algebra, and I get 7n minus 7. Okay, now I can find the value of n very easily. Okay, I'm going to say this is minus 1. I'm going to say, simplify this. Now I can add 1 to both sides. And what happens if I divide both sides by 7? I get n is equal to 707 divided by 7, which is 101. So now I found out that 706 is the 101st term. I'm going to write it like so. Okay. Not 100, but 101st. And that's a very important finding. We're going to use it when we use the Gauss's method to find the sum. So I know we are being recorded, so I can erase things because nothing is erased. You can go back and look at it. So I need the space. I'm going to delete all these. Now, I'm going to use the Gauss's technique and rewrite things in the opposite way. I'm just going to write 706 here. Now, if you want, I can write one more, 706 minus 13. Let me see. Let me see if I can find out. 706 minus 13. 706 minus 13 is 693. I can add one for 693. All right, guys. Now, I know things aren't lined up, okay? But don't let that bother you. All right, I'm going to claim each pair will add up to 712. An argument being, I can see this one, 706 plus 6 is 712, 793 plus 13 is 712. Let's check. 793 plus 13. Six 93 plus 13. Something going on here. Okay, my bad. Minor mistake, but we'll fix it, okay? My common difference wasn't 13. The common difference was 7. Everything is fine. But this is 699. Okay. This is supposed to be 699. Sorry about that, guys. Okay, I do that sometimes. All right, now things are looking much better. So what I did, let me go back. Let me go over it. So I determined that 706 is the 101st term. Fine, we did that. Now, if I subtract 7 from 706, I get 699. If I line things up and pair things up as follows, this is one pair, this is one pair, this is one pair. And I'm going to argue each pair will add up to 712 because in the first sequence, things are going up by 7. In the second sequence, things are going down by 7. It shouldn't have any effect on the sum. So I'm going to write a bunch of 712. Now, the question is, how many times do I have 712s here on line 3? How many times? The answer is easy, has to be 101 because the first sequence has 101 terms. The second sequence has 101 terms. We are pairing it up. So there will be 101 terms here. So if you add 712 plus 712, 101 times, what do you get? You get this. 712 times 101. I'm gonna multiply it here. I'm gonna actually wait, guys. I'm gonna wait. Now, I really want to find the sum of this line. So I take this, I divide the answer by 2. Why do I divide it by 2? Because I need to find the value of one line. No worries, we'll fix it. 712 times 101 divided by 2. I will use my calculator. And let's see what that turns out to be. 712 times 101 divided by 2 turns out to be this number. Turns out to be this number. All right, so we have it. So we learned how to do Gauss. Okay, now I'm gonna close this video right now, and I have 2 more small topics, really tiny, and we'll continue our lecture. But in this video, we learned a little bit about arithmetic sequence and geometric sequence. And you will need to know these things to do the problems in your text. Once again, if you have to read the text, I expect you to. And if you need help, with a particular topic, be very specific and feel free to email me. I'll see you in the next video soon.